participating that get cut off or weren't able to join, they can view this training online. And we'll be posting it on our website as well.
Okay. All right. So, Hafiday, everyone. I'm Mike Terlahi. I'm with the I'm with the Army Corps of Engineers. Sorry, I'm getting all confused here. So, yeah, I'm with the Army Corps of Engineers, and thank you so much for joining us today. Before we get started, I'd like to just set a couple ground rules for everyone. We have a lot of people on the call today, so thank you very much for your participation. But we do want to try and limit everyone's microphones and camera action and so forth, so we can have everyone focus on the presenters. So at this point, I'd ask you, if you can turn off your cameras and less speaking, and also mute your microphones. That way we can limit any outside noise and so forth. Okay, so again, thank you for joining us today. Today's call is, we were asked to, in a partnership with the Bureau of Statistics and Plans, DPW, and the Guam EPA, to come up with a simplified methodology tool to help calculate stormwater runoff. We understand that there's various different manuals that were being used, and we really wanted to streamline that process so that AE firms and our reviewers at Guam EPA and DPW could get a more streamlined type of tool that could really account and ensure that everyone was using the same formulas and whatnot for their calculations. So we're pretty excited about this. We hosted this in person last year as a kickoff with just Guam, with DPW and Guam EPA, and now we're expanding it out. And thank you for all the firms that actually joined on to today. So at this point, I'd like to actually turn it over to Mr. Matthew Santos from the Bureau of Statistics and Plans to give some opening remarks.
Welcome everyone. We hope that you guys find this helpful and use it as a tool to more quickly move through the permitting process, but also be more efficient in your designs. Again, we'll be reposting this on our website at bsp.guam.gov, where you can view all of the stormwater related materials, including the calculator. And once this is done, we'll be posting the video. But that's all I have.
Thanks, Matt. Okay. So with the Army Corps of Engineers, we have a couple folks, but I'll turn this over to Miss Jessica Brunty. She was one of our head engineers that helped in the development of the tool and was able to really look closely at the different manuals that we had and kind of get it streamlined. So Jessica.
One second, muted. Hi everyone, Jessica Prunty. I'm a hydraulic engineer with the U.S. Army Corps of Engineers, and I will share my screen to provide some background info for this. There we go. Okay, hopefully you're all seeing that title page. See. Okay. So just to provide some background on, we've had several different manuals related to storm drainage in Guam. So starting with in 1980, the U.S. Army Corps of Engineers developed a comprehensive Guam Storm Drainage Manual. Historically, stormwater was viewed strictly as a drainage issue and was routed to the nearest discharge location, infiltrated into the highly permeable limestones with little or no pretreatment, or conveyed directly to receiving waters. The governor of Guam recognized that the 1980 manual was in need for updates based on significant rates of development, advances in technology, rendering better and optimal designs. So in 2005, the CNMI and Guam Stormwater Management criteria was finalized after public meetings and a comment period. This set of criteria is a set of unified criteria which provides a framework for standards pertaining to comprehensive management of stormwater. And these criteria provide proposed standards to augment groundwater recharge, to achieve water quality protection, prevent accelerated stream channels, prevent erosion, reduce flooding threats, and preserve sensitive habitats. Sticking with the timeline here, around the same time, Dr. Lander from the University of Guam published the technical report number 103, Rainfall Climatology for Saipan, Distribution Return Periods El Nino. And in this report, return period calculations for Guam's peak annual 24-hour rainfall yields a mixed distribution with typhoons. In layman's terms, normally we refer to like NOAA Atlas 14 for our precipitation frequency data, but that's, could we mute that person? Thank you. So normally it's based on an annual maximum time series. You look at the complete annual record. And what he is suggesting is that rainfall and typhoon events you should look at the statistics differently because they're different types of events. So he kind of plotted out that these smaller frequency events should be based on the rainfall, and the larger events should be based on the typhoon statistics. So that's something we've started to adopt in our flood studies, and we end up using some of this in the spreadsheet that we'll talk about later. So again, the 10-year is like the threshold for the different types of data. Executive Order 2005-35, it basically said that DPW should use the new criteria, but at the time, private development didn't have to they could still use the old standards. Then in 2006, the CNMI and Guam Stormwater Management Manual was completed, prepared by Horsley Witten Group. And this manual was based on the CNMI Division of Environmental Qualities and the Guam Environmental Protection Agencies identified the need for a new guidance manual and for developing and implementing stormwater and erosion control plans that adequately address non-point source pollution through the use of currently accepted best management practices. So they came up with a new manual. And it was intended to replace previous reference manuals. They also came out with a second volume. Volume 1 was provided the general overview, and Volume 2 contained the technical information needed to actually design a landscape. And these are reference materials that we also used in the development of the spreadsheet. And also worth mentioning that in 2010, there was the Island Stormwater Practice Design Specifications. And in 2009, there was another executive order that said we still don't, application of the criteria was stayed for 2 years. They came out with the Transportation Stormwater Drainage Manual in 2010, and this manual was intended for use by DPW's highway staff. So a couple different manuals, different uses, but this latest executive order 2012 says Guam CNMI and Guam stormwater criteria for all non-transportation construction projects and construction projects in private property should use that this previous standard, these previous standards that were developed, but the that all the transportation projects would use the transportation manual. So there's a little bit of a difference there, and the spreadsheet was specifically developed for the non-transportation projects. President concurred the need for just additional clarity in the and updates to the manual. So that's where we're at. Mostly, I have additional slides on the background as questions come up, but I will kick it to Tyler now so we can jump into the spreadsheet. Okay.
Thanks, Jessica.
Yeah.
I'll give a second in case there's any questions on the background of what we're talking about. And then while we wait, I'll go ahead and share screen. So I was going back and forth on how I wanted to do this training. I think the best way of doing this is actually sitting here and inputting numbers and talking through each tab and whatnot. You all should have received a zip folder that had all of these attachments here that you see on the screen. I'll quickly go over these so then you have an idea of what we're all talking about. So this presentation is, actually have it on my side screen, and it's a really helpful sort of instruction manual that I put together to have on top of the training and whatnot. So if you came back and had questions, and it really goes and gives a lot of information on how to do this spreadsheet. So if you have this available, I would recommend having it on the side while you watch, just to try to follow through as we move forward. And so that's the PowerPoint. And like I said, it's kind of like an instruction manual. The Word doc is an actual example that was taken from the CNMI manual that Jessica just briefed us on. It's examples that were like, projects, and they went through the entirety of the example and inputted everything into this Excel sheet. And that product is this Guam example for part A. So that is a filled out spreadsheet with all the numbers. And this is heavily in depth. It's like 55 pages long, and it goes really in depth on not only what you're inputting, but also how the outputs are calculated. So if you're super curious on how formulas were made and whatnot, this is where you go. And then these are the two manuals that we're basing a lot of things off of, the CNMI volumes 1 and then there's also the TR55, which is a graphical method, which we'll use on the third tab. So that's all the things that should have been included as attachments. And then from there, I think it's best we just get started and we just dive right into how the Excel sheet works. Big overview is you have a ton of tabs down here at the bottom. And the way that the Excel sheet works is you work left to right. So you start to the far left and you work right way. The first 4 tabs are all sort of, think of it as like H&H modeling and design. So it's understanding, you do all these tabs to figure out runoff volume, peak discharge, sort of the cogs behind the machine. And then after that, you become a designer now. So now you have to select what sort of features are planned or you're thinking about for your project. So they have an infiltration basin, detention basin, swales, bioretention, and sand filter. So those are the options, and those are all based off of the CNMI manual on how to design them and whatnot. So for background, I'm a designer, and so the right side is a little bit, makes more sense, and then the left side's a little shaky, but nonetheless, we'll figure this out together. The teal on the Excel sheet is your actual inputs. This is where the Excel sheet is asking for you to put something in. The yellow are already generated output, so you don't have to do anything here. These are things that the formulas in the background are calculating. And a lot of times, if you're curious, you can just click on them and kind of get an understanding just from, general Excel world. So the first thing that we're looking at is it's trying to create the runoff curve number, which is basically how quickly does water run off of the surface. And so the first thing you have to determine is the cover type of your project area. And this can be done generally by Google Earth or whatnot. So for the sake of what we're doing here, we have different cultivated agricultural lands, woods, meadows, fully developed areas, parking lots, residential district. And then something that's super useful is a lot of these, if you hover over there, they tell you what's poor versus good. So there's a lot that can be utilized here. So this is part one, is figuring out what are your cover types. Part two is determining which of these columns are you going to be in, A, B, C, and D. This is pre-development and this is post-development. So the A, B, C, D is based off of the soils. So at the far right of your Excel sheet, you'll come to the soils tab and you'll see here soil name and then the HSG group. So the way you figure out what your soil group is you actually go to this website here, which is the Web Soil Survey from USDA, which, in case you're wondering, the link is within the PowerPoint manual. And what you want to do is when you open up the link, it's going to ask you where you want to go. Guam is an option. And then you can zoom in on a location. So for the sake of this, I'm just going to kind of zoom in a random area, right? And what this does is you then decide what your area of interest is. So for this example, let's say that this is a sort of residential area down here. Let's say that we're going to expand upon it within this sort of woody area. So if we decided that our project is going to take out this wooded area and become residential, you can go ahead and close this. Maybe. Of course, it gets stage fright once I'm doing it. There we go. So it shows you the area you hatched and whatnot. And if you go to this tab here up at the top left and you go to soil map, it will actually tell you the type of soil, the acres, and the percent. Super helpful. So for this example, let's say we're looking for the clay 7 to 15% slopes, right? We have 8.6 acres. So what you would do is you would take this information and you would find that clay within the soils tab.
I can take that, throw that in my detail.
Here it is, 7 to 15%, and it's class D. Okay, so what you would do with that number then is you would figure out where was that number. It says it's map symbol 34, which is this area here. We could probably delineate this as a woody habitat, maybe poor condition because the trees are kind of sparse. So if you were to put this into your runoff curve number with class D, which we found from the soils tab, we go back to that first tab, we would find
are in a sense, but for the most part,
it's a woods with a grass combination. And we could say, so it says pours 30% ground cover, litter grass brush, fairs 30 to 70, good 70%. Here for this sake, I'm going to say fair, and then I'm going to make sure I'm in with category D. Okay. So now I can put, I'm just going to say a random number here for now, but say it was 5 acres. Let's say that our project, we did the soil map. We figured out all of the areas, 5 acres of fair woods. Okay. What that does is it takes this CN value, which is from I think it's from CNMI. Maybe it's TR55. This is a H&H number. It takes that and then it gives you a area times CN number. And so it just takes the number you put in times this by this value, and then it gives this value. And then at the very bottom here, now all of a sudden you'll see total acres, which is 5, and then a composite runoff curve number based off everything. So if you had multiple different places with different groups and, you know, whatnot, you come down and your total acres would change, and then your curve number would finish. One nice thing is that there's these macros built in. So for this sake, if I just want to reset it and clear the data, I can just click reset and then it will just clear all the data. So I'm going to just, for the sake of teaching, I'm just going to choose a value and I'm going to put this in and we're going to work through it for this. So I'm going to say that we have a project that's 5 acres total and it's all pasture land. And we're going to take that, we're going to keep 3 of those acres are going to stay as pasture land, and I'm going to say that 2 are going to become townhouse, half or eighth of an acre residential area. So 2 of those acres we're going to convert. So let me make sure I put it in the right. So what I just did, just to like clarify, on this left side, this is pre-development. This is before you've done anything. And then we have our right side, which is post-development. So now I'm saying that there's 3 acres that are still meadow, but then 2 of those have become residential. One cool thing as well is that it tells you the average percent impervious, which we'll need later. So this is also super useful. But if we scroll down to our bottom, the big thing is to make sure that our total acres equal up, that your pre and post should be the same. And then you have your 2 numbers of 80 and 79. I will pause here. This one is a very heavily loaded first sheet, a lot of information. I'll pause for a second to see if there's any questions. Go ahead, Ed.
Yes, this is Ed from DCA. I saw earlier that you splashed the Google image. Is that that image is being updated regularly, or I don't know how often they are being updated, but the condition change over time. So if the image is not updated, the condition is different. So how do you take that into account?
Yeah, that's a great question. That is a good call. Yeah, this is a USDA, and I'm not sure how often it gets updated. So, I mean, you have Google Earth as an option as well. But once again, if it's the survey data is super old, I would just recommend maybe a preliminary site investigation be conducted. Yeah, so that is a very good question. Is making sure that the land cover is chosen correctly, and I think that's where it's going to be a like best practice between the agency and the AE firms to make sure that whatever the AE firms are saying is the cover, that the reviewers or the permitters are agreeing with that cover type. So that may be something that goes back and forth.
Okay. Good answer.
And Tyler, there's you might not be able to see this because you're sharing the screen. There's a question in the chat. Why did the soil group change from D to C?
Oh, that might have just been me. Did I change it to C on accident? Oh, good catch. That was a great catch. Yeah, that's a good call. Is like if you're in an area and just because your cover type changed, your soil type didn't, right? So that should stay D because your soil's not changing, but your cover type's changing. Okay, so thank you for that catch. And then I see another hand up. Ken?
Yeah, thank you. Good one. This is really good stuff. Thanks for this. I was just gonna tap on Ed. This is Ken from DCA. Yeah, Ed's question is good one. But I think Ed, that all those layers in the on the GIS map that was shown, those came out of an old reference that when the soils were mapped, and I think just the image is updated regularly, probably by USDA. But that base layer of the soils, I think that's just an old layer that, like the what's his name was saying, it just needs to be visually verified out there just to make sure there was no significant major change. So yeah, I think a site visit for larger sites is the right way to go, or at least some sort of updated check.
Yeah, thank you. Okay. I'll keep moving on. Like I said, this sheet is very heavy, right? And we just did a really quick thing. But if you're one of the designers, this could take some time, right? Jumping back and forth between soils and land cover and try to get that connection between the two. And I think it's a good spot to talk about the fact that when you're using this tool, it's not at the planning phase of the tool. It's almost like you're at like a 10 to 30% design. Like you have an idea of what you want to do, and you're using this tool to make sure that that idea is going to follow the standards and regulations. Oh yeah, so just wanted to put that out there as well. Okay. So we can now move on. So we have our RCN value down here, 80 for pre, 84 for post, which makes sense because we've changed the land type. We went from meadows where there's ways for runoff to slow down and whatnot, and we've gone to a area that's now more impervious with asphalt and sidewalk and whatnot. So your number is going to be higher because now water is able to flow faster, right? So if we move on, we now move on to time of concentration. So there's two ways to do time of concentration. There's the easy way, and then there's the you have to figure it out way. The easy way is somehow you already know your time of concentration for the area, right? That maybe isn't feasible. Maybe you're doing this from scratch. But if you do know that number, you get to basically cheat this and you get to go right to here and put it in, okay? For this sake, I'm going to go ahead and go through what it looks like to actually put this out. One thing that's important to think about when we're talking about time of concentration is it's a little bit different in terms of visually where we're at. So RCN was very intimate, the 5-acre site. Time of concentration is focused on the actual watershed in its entirety. So if you're near a stream, the time of concentration would like to know everything about that stream. So from up to down, sheet flow is basically the top of the watershed a lot of times. So it's where rain just hit, it hasn't collected, and it's basically a sheet of water. So if you would imagine, it's almost like if you had a granite, side of a cliff, and water just kind of flows down it with no sort of rhyme or reason. That's your sheet flow. And that, on top of that, which this is also specified in the PowerPoint, the best practice is that the length of the sheet flow shouldn't be more than 300 feet, which is pretty practical. If you have sheet flow, it's not going to take long for water to figure out what it wants to do and make itself a stream or creek, right? So for the sake, let's just say we're looking at this place and we see for 200 feet, there's some sheet flow, and we're going to say that the slope is, I'm going to say because it's a cliff and whatnot, probably that we're at like a 2-to-1, 0.5, right? And then the last thing it wants to know is surface. The surface codes for sheet flow are found right here. So you have smooth surface, fallow cultivated grass, range woods, whatnot. So because I just talked about like a granite side cliff, I'm just going to say smooth surface for the sake of the training. So the cool thing is you get to just put the letter, and then it determines the mannings based off your code, and it gives you your travel time. So that's pretty helpful. Next, we go on to shallow concentrated. So this is where we've now transitioned away from sheet flow, and now we're looking at not necessarily creeks, but small, very, very small, like almost like what feeds into creeks. So it's like sort of ditches that are most of the time dry, maybe, but a rainfall event happens and all of a sudden a ditch is filled. That's what your shallow concentrated is. It's not established creeks or rivers or channels. It's just like, small pond or smaller than creeks, right? So this is once again one of those things where it's going to be an interim process where maybe the design engineer thinks that this portion of a channel isn't a channel, it's a shallow concentrated, right? But then maybe the reviewer, like EPA for instance, thinks, no, this is an open channel. So there's going to be that like back and forth determining this. And I think it's really important that when you're going through this, you're not just filling the entire thing out and then submitting. To me, it makes sense that it's like it's an iterative process. Like you guys get buy-in on the RCN and you move on from whatnot. While we're talking about this AE to reviewer sort of connection, this is something that's super helpful, is there's a macro in here for each of these tabs to print out the sheet. I'll just show it real quickly what it does. But it basically captures what you're talking about. And then what's useful about that is if everybody's using this tool, when they print these attachments out, now you just created a standard that everyone's following. Everyone's printouts look the same. Everybody's values, make sense. It just like streamlines the whole processing. Sure where the print went, but promise me it's doing it somewhere. All right. So shallow. So once again, I'm just going to go ahead and put some random numbers in here just so we have an idea of what we're looking at. So I'm going to say for 100 feet, we have a 10% grade. And then what's going to change here is our surface code. So before we were looking at sheet flow, now we're down here looking at shallow surface codes, which are from NRCS. I'm going to say for the sake of this, I'm going to say we came off of a cliff and now we're in sort of like a grassy meadow, right? So I'm going to say a grassed waterway. You put the number that it associates with, and once again, it determines, it outputs for you. So you don't have to like put in the like background work. And once again, you do this for the watershed that you're impacting or affecting or within, right? So there could be multiple of these shallow concentrated. It could be more than just one, but for the sake of time and whatnot, I'm just showing a single one. And then you move on from there to open channel. This is where you get into your creeks, your rivers, your whatnot. So I'm going to just put for now 1,000 feet, and I'm going to say it's a, 5% slope. And then for Manning's number, we have it, I believe it's in the lookup. Yeah. Sorry, I just jumped there without talking to you guys about what I did. So next to the soils tab, there's a lookup tab. And this gives you Manning's numbers and runoff coefficients and a lot of like interesting information that you may have questions about and need more. And there's this sort of background information of like the rhyme and reason of what's happening. So if we say, let's just say it's a, grass short channel, right? Then we could just go ahead and put 0.15, 0.15. And then area, square feet. So this is if you measured it from the satellite. What's your bank to bank? If we say it's 50 feet, or sorry, square feet, not width. So then this would be the actual like area of your entire, let's say it's a lake or a channel, whatnot. This is what you see from satellite imagery or whatnot. Basically your wetted area. So this is in square feet, so it's going to be a decently big number. Let's go ahead and just, for the sake of it, put 50,000. Oh, that's 5,000. And then wetted perimeter. Let's say, just for the sake, let's say 15. And then it's going to give you a number. That's a huge number. So I put something in that's unrealistic. But for the sake of learning, I'm just putting in numbers at, that don't necessarily make sense, but they're there to like show as examples. So that's sort of how sheet and shallow and open work. And then this is pre-development, and then post-development. A lot of your sheet and shallow are probably going to stay the same because you're probably, well, I say probably. I'm in my head, I'm thinking if you're doing a residential, like I'm using as an example, you're not way up at the top of the watershed. You're pretty much down at the end of it. So what may happen is that most of this that changes is going to be your open channel information. You may be introducing a new open channel configuration in the form of a swell. It may be in the form of a detention basin. It may be, and so that's the where you would put that in, and then you would result in a different time of concentration.
Yes.
Typically, your time of concentration should decrease if we're in the terms of creating more impervious area, because time of concentration is basically the time it takes for water to accumulate and hit basically a flow velocity.
Mark up
I'll pause for a second on this sheet.
the drawings.
Go ahead, Jeremy.
Yeah, quick question on the sheet flow. What if you had multiple sheet flows? What do you typically do in this
Yeah,
spreadsheet?
yeah. So I believe if you just grab this guy and
How confident he is.
insert, it'll just.
It says that the document was.
So like for the sheet flow, I mean, unless you're doing separate areas, leading up to it, you really, it's just supposed to be represent like the longest flow path, right? So, and it's not really supposed to be more than 300 feet.
Correct, but I guess just in the case that you had, it went from grass to pavement, maybe that's not always the case, but you had one iteration that from a splash block down, it went through. What, can you just add another row, or do you just average something out in that case?
Yes, yeah, you could take it, add another row or average it.
Okay, thank you.
Step-in's your guys' supervisor.
Yeah.
And Tyler, one from the chat, the area is in this spreadsheet is the cross-section area of the channel.
That helps me. I'm used to doing this by just putting in this number. So when I was looking at this again, I had forgotten a little bit about it because usually I'm blessed with having that number at the bottom already. Okay. Julio, so keep moving on. So I'm putting in right now, just for the sake of having numbers to populate the sheet as we move forward, I'm putting in the numbers that they provide in example 4 part A that was included. So in case you're curious where I just type these in, I'm just typing them in to have numbers to populate outputs later on. Oh, and then last little piece is there's a 2-year 24-hour rainfall value here. This is based off that Lander report that Jessica had talked about previously, where it's trying to account for monsoons and rainfall data and whatnot instead of just using NOAA Atlas and whatnot. And so you'll see in a couple of spots that like rainfall's already populated for you, even though it's a teal. And that's because most of it's Lander or TR55 or CNMI. But for the most part, you shouldn't touch these unless, I guess, otherwise directed. Okay. Okay. So moving on, the first thing you'll see in the TR55, which is the peak runoff calc, you will see the drainage area and the runoff curve numbers, and they're yellow. These are because they grabbed them from that first sheet we did, those like final summaries that we saw at the very end. This, for the most part, should be a pretty straightforward sheet because there's a lot going on in the background. The only thing you really need to focus on is the location adjustment factor, which I'm going to really quickly show the PowerPoint because it gives you the figure that you're supposed to refer to. This little figure here on the right is the Guam map with the different location adjustment factors, and this is based off of figure 2.6 within the CNMI manual. Based off where I did that soil survey in the very beginning, I'm just going to go ahead and put 0.9 for these location factors. Okay, so once again, this is pretty straightforward. You just have to know where your project's at. Matthew?
Can we just clarify this is it's not just the CNMI manual, it's the Guam manual as well? Moving forward.
Yeah. Okay. I can call it the Guam manual. Yeah,
It's
sorry.
not for the CNMI. Yeah.
Right. Yeah, that's totally fine. Okay. So this did a lot of background calculations. It did total 24-hour precipitation, peak discharge, runoff volume, whatnot. We will be coming back to this here and there when we get to the actual like design features when we're trying to design like a basin or a swale. We will come back and look at these numbers. Some of the big ones we look at is like runoff and peak discharge. Sometimes we want to know what the 50-year looks like or the 25-year to make sure that our basins are functioning properly. Okay. Now onto runoff volume. So again, we talked a little bit about the rainfall data with the Lander report. And so these are already pre-populated based off that, so they don't really need to be manipulated. And then one of the things you're going to start seeing in the rest of these sheets is sort of like deja vu, where it wants to know the geological region and the water quality region, and then this table here. The region can be determined once again from the manual with this figure here from 2.1. So based off where we were, we're about right here where my cursor is in S2, which is a green polygon, and green delineates limestone. And then another thing you'll see is these different indicators, S1, S3, M2, S2. That is your water quality. So based off the example where I took the little soil survey within S2 in limestone, because it's green, we can go ahead and input that here. So we change our geological region to limestone, and then it's already preset to S2, but it has all the options there. So once again, there's also a call out to let you know to go to that figure to find those values. Now, this cover description table is based off of what we did in the first tab. So there was a couple times where I was thinking maybe this should just auto-populate, but one of the reasons it doesn't auto-populate from the RCN table is because there is the ability to figure out CN values from the TR55 methodology, which are on figure 2.3 and figure 2.4. So there's another way to figure out CN value, and so that's why it's been left. But for the sake, we're just going to use the RCN value, which we calculated before. And so the CN value was, pre-development was 80, and it was 5 acres. This was 80, and this was 5. And this was HSG Group D. If you wanted to get more into it, we could put meadow, or sorry, good pasture. Right, and then I'm going to put residential for the next section. So we have good pasture on the post development, but it's at 3 acres. And then we have residential townhouse. We have it for 2 acres at 92. So one thing that's a little unique here is this, we need to do a little bit more than just this. We need to provide the total acres of impervious. And so in our example, it's a little straightforward because we only have one area that we're delineating as having potential impervious based off this average percent impervious. So for this example, we said that 65% of your acreage is impervious. So if we did like a quick calculation, that would be 1.3 acres of your area is impervious. So what we need to do is basically copy what we said and then break this 2 acres into impervious and non-impervious. Let me just make sure. So 1.3, is that correct? Yeah. 1.3. And oh, this is a great time. One of the things that the table does is because you have to break this up like how I did here, it could get complicated and you could mess up acres and whatnot. It will go ahead and give you this error call if the acreage doesn't match the pre and the post. And so in this case, it doesn't right now, but now it does. Okay. Right, and then it does some calculations, storage factor, runoff volume based off these numbers. And then the storm adjustment factor was that first figure I showed earlier, which was the blue figure with the purple and whatnot. And we delineated our area at 0.9 based off where it was. And then there is the volume factor, which the sheet does a pretty good job at telling you what to do. One thing is we're limestone, so ours is pretty straightforward. It's just 1.5. But if you were volcanic, the way you determine your volume factor is by which HSG group dominates. So you wouldn't base it off an average of all of them. Instead, you would base it off the dominant HSG group by acres, which is sort of helpful since this gives a percentage. And so if I was to do this, I could say that 43.3% is Guam Urban Land Complex. And let's see, so just for the sake of understanding, Guam, I'm pretty sure that's going to be Group D. So if it wasn't limestone, if it was volcanic, the dominating group's D, so I would change this to 0.1. Okay. Project area, once again, we decided it was 5 acres in this sense. And then project site impervious area in decimal is, let's see, so we had 1.3 out of our 5, which we determined by that percent impervious earlier. That would be 26% of our site is impervious. I'll stop there for a second because I know I just went through a lot. Is there any questions at this point on runoff volume? Okay. The last thing is water quality. Oh, did I hear?
No. Oh, I was just gonna say there's no questions in the chat.
Okay, perfect. And then last thing is water quality site designation. The Excel sheet does pretty good at already giving you that designation here based off your region and your water quality region. But there are some instances where moderate isn't a good call. Sometimes there are hotspot locations. It's found within table 2.1 for hotspot. So this is like industrial sites, marinas, public works storage areas. There's a whole classification on what would be determined as a hotspot and whatnot. Okay. So there's high and hotspot and then moderate. But since where we were looking, there was nothing really out of the ordinary, I'm just gonna choose my water quality site designation to be the same as what the Excel sheet generated for me. Then what that results in is a CPV value or stream channel protection volume. And we will use this number will pop up a couple times as we move forward. But that's what pretty much the sake of this sheet, or I guess pretty much all the sheets leading up to this point was to get that CPV value. And then the last question to ask is your impervious area less than 1 acre? Based off of what we inputted here, we would say no, and you have to continue. And it pretty much outputs some additional information. Your overbank flood control volume is the big number out of here that will be included later on in your design choices. Because your impervious area is greater than 1. If you said yes, it would just tell you that it's not required and you can move on. And it gives you these runoff volumes down here.
Whatever B sheets are in there.
Okay. Oh, one extra little tidbit. The QP25, the overbank flood control volume, there's a little disclaimer. I believe that's in the Guam manual that says that if there's no downstream structures in a designated floodplain or it discharges into a lake or reservoir, stream or river having a drainage area greater than 5 square miles, or discharge to a tidally influenced area, that it's not required to have this overbank flood control volume. And I think there's more information about that within the Guam manual, but it's just a tidbit that's not really talked about here.
So gorgeous.
Okay. So at this point, we've pretty much completed the pre-design information. We now have numbers that we've done from these 4 different tabs that are going to be incorporated into your design choices: your infiltration basin, your detention basin, your swells, your bioretention, and your sand filter. So, like I said earlier, this table keeps coming and coming again. So here it is again. I'm going to go ahead and input these as we had it before, as we discussed. It's volcanic. There's S2 based off that figure earlier. And then these values that I'm going to put here are the exact same as the sheet before. We had said 80 and 5. Also, you can just put in the weighted CN value here if you'd like. But you want to make sure you put in your area of your impervious still, because it's important for the later on factors. So usually best practice is just to refill out the table just to make sure everything's working correctly. Once again, I'm just filling out the numbers to be the same as last time. Oops. Now what it's doing is it's doing the runoff calculation, which I believe is the same table as what we've just seen. Our storm adjustment factor was 0.9. That was from that first figure I showed, the blue figure. It's going to come and come again. It's 0.9. And then here's this question that I pretty much had just talked about, was that QP25 number. It was the talk about they're not required. This pretty much tells you what you need to ask yourself. So it says, does the proposed project result in runoff that will impact any adjacent properties or result in flooding of the developed property if the infiltration basin is filled beyond its design capacity? Then your yes and no basically are going to influence which of these 2 tables you're going to use. You're either going to use infiltration basin using total storm or infiltration basin using net storm. And it tells you which one to use. It says, if yes, use analysis 1. If no, not result in runoff discharging throughout the property before reaching a public stormwater, and the proposed development will not flood when you may use analysis 2. So analysis 1 is the more stringent, and analysis 2 is the less stringent. And this blip here about when you can say no is what I had said earlier about the QP25 value. And then also, if you're following along with the PowerPoint, you'll notice on the infiltration basin sheet, which I'll go ahead and show here, it actually gives a criteria based off the Guam manual of whether or not you should even use the infiltration basin, which is super helpful when it comes to making design. So it tells you status if it's okay or not. So we said yes for this assumption. And so we're going to be here within the analysis 1. The first thing it's going to ask about is infiltration rate. You determine infiltration rate from your soils tab here to the right. So for this, I'm going to just decide for fun which one. I'm going to go ahead and say, sand at 0.138. I'm going to say we have a pretty good site for infiltration. It's real sandy. The water's able to infiltrate into the, let's say there's an aquifer or whatnot. It's real easy. So let's go ahead and go with that. I go ahead and put in that number that I just determined. And once again, the infiltration rate is based off the soil of the area you plan on making an infiltration basin. It's not necessarily like a predominant soil group based off the soil maps. It's based on the soil group of where you want to put this thing. Okay. And then from there, this is where you can put an estimate of what you think your length and width of your basin is going to be. And, you know, this could be, you know, you have a preliminary site design and you decided, you know, I can fit approximately a 100-foot long basin and a 100-foot wide basin. Now what you're going to say is your Z, which is your side slope. So Z is your horizontal and then it's assumed a 1 vertical. So for this case, if we say a 2-to-1, what it now needs to do is it has this function here, infill 2, that will basically go through these calculations computed with a lot of pretty cool tech that will then determine how deep your infiltration basin should be based off the design volume that we talked about earlier, based off of the precipitation. So all these different tabs are coming from, or all these different numbers are coming from the tabs we had worked on before. The last thing to do before, if you do want to use the infiltration button, is if you're thinking of using an infiltration trench, so like a grassy swale ditch, but instead of it just being a grassy swale, it's actually got some sort of infiltration potential. Let's just say for this sake that it's limestone aggregate, like it's saying, and let's say that it's going to be 1.5 feet deep. That's going to help take away from the depth of your basin, which I'll show here. So if we click this button, oh no. Maybe I did something wrong. Maybe I pressed something wrong and it just didn't want to do it. They're just getting stage fright. I apologize. This shouldn't be happening. I think maybe it's because I need to put in this number. Give me a second. Okay, well, for the sake of moving on, because I know that it might have been just from me playing around in this a little too often, which is something I'll make a note of to make sure the macro works correctly. If you have one that's functioning, which this is from Guam example part A, which has all the numbers. Let's say we change some numbers around and the AB2 and AB1's moving around. What you can do is go ahead and click this and it determines the depth by the trial and error number. So to show that again, say you change your width to 200 and your side slope to 2-to-1. Focus on this number here is 18.8. If you click this, now all of a sudden the depth of your basin has to be 38.5. And that makes sense. You've reduced your area pretty much. Your functional capacity of your area, so now it needs to be deeper in order to still withstand the design volume. So if we increased our area at the top of the basin to 50,000, this should, there you go, the depth changes. So this is a pretty neat tool to help you determine the depth of your basin and whatnot.
Excuse me, this is Ed.
Go ahead.
Yeah, I wanted to clarify the values of the length and the width. Is that the top or the bottom of the basin?
I believe it's the top.
It's the
I'm
top.
pretty sure it's the top of the basin. Yeah.
Okay.
And there's also a question in the chat if you could do a site-specific infiltration test and use that instead. And I guess if I were to respond, you know, I think in the spreadsheet that would work. You could just put the number in, but we'd have to circle back with maybe Guam EPA if they would accept that.
Right. I'm just making a quick note on probably putting a
Hey,
note here on
Tyler.
the side to say that. Go ahead.
Yeah, this is Mike. Just for, you call your break whenever you think you need it. And I think we have you we're ending at 11, if I'm correct. So whenever you feel you need to take that break, we can take a short one. Just whenever you feel is a good part in your thing.
I think now's probably a good time. I think. Thanks for calling that out. This is a good spot probably to stop. I probably should have stopped once we finished out the design portion, or sorry, the pre-design, and moved on to the design issue. If we don't have any questions, how long do we want to take break for? Do you have a preference?
Yeah, this is Ed again. I have one more. Earlier you splashed the classifications of stormwater hotspot land uses. Are those the same as what it was outlined in the CNMI Guam Drainage Manual? Are they the same?
Yeah, I can actually. Let me pull up the manual and we can make sure that that's still the case. I might have too many tabs open at this point.
Get the same grade. Both about all the. Well, yeah. Okay. That is these emails in the show. True.
Okay, so based off the PowerPoint, it's in volume 1, table 2.1. So table 1.2. There it is. So this is designation of stormwater hotspot land use 2.1.1.1. Your table here that gives different land uses that are determined as hotspots.
Yeah,
So yeah, once again, I think this is like really important to show how the Excel sheet's a tool that's completely based off of a lot of these standards and whatnot. So I think if there's times where you have questions or you're confused, there's definitely the resources to try to find it. Like this is kind of like the specifications of the contract in a way, right? And the Excel sheet's almost like the drawings or the plan set, right? It just shows the design. It doesn't necessarily go into the nitty gritty as to how you came up with the design, if that makes sense.
Yeah.
Is there any other questions?
So my question is, are these exactly the same? What you splashed earlier and this one with the manual? Are they exactly the same word for word or different?
Yeah. The manual hasn't changed. It
Okay.
got finalized, I think, 2008. Is that right, Jessica?
Right, and it's the same as what's in the spreadsheet.
Yeah.
Okay.
So this is a good segue for us to take a break, I think. I say maybe we get ourselves a 10-minute break.
Okay.
How does that sound? And then everyone can regroup, get some coffee, and then we'll rejoin. So we're at 9:12. Let's try and get back here by like 9:20, 9:22, if we can. All right.
Thank you.
See you guys back here, 9:22. Thank you. All right, I hope that was enough time for everyone to stretch their legs. We should be resuming shortly here. Tyler, you're ready?
Yep.
Thanks.
Share. All right. One thing I wanted to also talk about was the required versus optional stuff. So I'm going to go through every single tab, but that doesn't necessarily mean that every single project needs an infiltration basin or a detention basin or a swell, right? That's determined by the designer and site constraints and all that sort of fun stuff, right? So you may be at a site location where an infiltration basin is not feasible. And that's what all these tabs are beyond runoff volume is they're based off what you think your 10%, 30% design is, right? One thing I was thinking about is the depth of the basin trial and error work if the macro for whatever reason isn't working, like it's not been working for this class, which is strange because it was just working. If for whatever reason it can't get fixed, whatnot, there is this simplified infiltration basin which actually allows for you to do what the macro does, but by trial and error. And so I guess really quickly I can show what that does. So if I put in some numbers, do I need to re-put in? Of course I need to re-put in these numbers. I just wanted to show what this can do if you wanted to, instead of letting the macro determine it, if you wanted to sort of affect numbers manually. Said this was 0.9. Okay. We said yes earlier. Okay. And then area at the top of the basin, let's just say it's 500. Let's say we want it to be 5. Okay. So what this does is it calculates, we said 5, and what this does is it calculates this AB number, 72,000 surface area bottom in square feet. What this is going to try to do is get this infiltrate this size error, the V infill minus VW. So if we went ahead and we said 2-to-1, oh, also this helped answer that question earlier. Oh, never mind. There's bottom as well. I was curious if it was going to say top versus bottom, like we had that discussion earlier, which we'll have to put in a note later. Okay. So what this says here, this bottom number, it says size error, and then it says here, make this positive and as close to 0 as possible. And what it will do is it'll do a check, and if it's not near there, then it's going to say error. So if we need to get this close to 0 as possible, we can start changing these numbers to get it as close to 0 as possible. So this says okay, but it's really far from 0. So if we really wanted to get it better off, okay, so that wouldn't work. But as you can see, I'm just kind of putting in numbers based off different things. So this is kind of helpful if you're in a really constrained area and you have like constraints you can't be messing around with and you don't want to use the macro. This is a better way. So say you're confined to a top width of 500 and a top length of 250. Like you have determined by either looking at maps or whatnot, or you have a preliminary site area and you set aside an area to be your basin, and you said, okay, the very top of it can only be 250 long, 500 wide. Like there's nothing I can do about that. You can then say, all right, let's see what a 2-to-1 is going to do, and you're going to see a size way too high, and then you can say, okay, well, all right, let's keep it at 2-to-1, but maybe let's make it 5 feet deep, right? And okay, now it's getting even bigger. So then you know, okay, well, so it's pretty much just like a you kind of just sit here and change the numbers until they get close to where you're trying to get. So it looks like these two widths just aren't going to work. But long story short, that's what this simplified infiltration is taking away the macro and doing it manually. I wouldn't recommend doing that. Just because it can get funky sometimes, and all the examples I've seen always use the macro. And the Excel sheets you've been provided don't have that bug like mine does. I think it's just from so many runs of doing numbers that technically aren't making sense, but I'm doing it for the sake of understanding that it bugged it. So that's infiltration basins. That's the first of the different design configurations in a nutshell. Okay, and then moving on to detention basins, I think this is probably one of the most in-depth tab. So this one may take a bit of time to like go through, and I'll do my best not to bug out the program again. So the basin starts with the drainage area, which is determined from the total project area, so 5 acres, right? That's what we had said earlier. And then there's a detention pond classification choice, which I believe right here. So on the Excel sheet, there's a P1, P2, and P3 where it tells you wet pond, micro pool, and wet extended detention. And this is found in Chapter 3, Figure 3.1, Figure 3.3, and it goes into depth about what these different pond classifications are. So these are different design choices, right, that to use when determining it. So for this example, I'm just going to select P2 for the sake of this. I want to make sure, I want to understand why this is showing up as negative. Recharge volume, runoff volume. So this is just, sometimes numbers don't add up correctly, and they result in negative numbers and whatnot just from the example. And so, it's a good check too on when you're doing your design is seeing why some of your numbers may be negative, because maybe you put in numbers incorrectly, or it's just not sounding out logically with a lot of the formulas. We'll see what happens when it's negative. I can't imagine it's going to be good, but we'll see anyways. We'll keep moving forward. So the next thing that it's going to look at is we're going to basically slice this like a cake of your detention pond. And so what we're going to do here is we're going to take the basin floor, and this is like true elevation, not just relative. This is absolute elevation. So example 4, part A has a at 381. I'm not sure here in California we use NAVD 88. I'm not sure for Guam what the sort of typical vertical is, but that's what we're using here as an absolute, and then for the sake of the example, use 393. And then what the elevation increment is that those slices of pie, it's pretty much how much information or how in depth do you want to get with your area and your cumulative volume and whatnot. So if you do an increment of 1, it is going to auto-populate this down here, and it's going to give it an increment of 1, right? But say you wanted to do 2, it's going to go 381, 383, 385. It's going in increments of 2. That's how this is set up. We did 5. It's going to do it in increments of 5. And it shows it beyond your elevations. But when you put in your square area, obviously you want to put in something beyond 393, because after that, it's not, your basin's no longer available. So if you do 1, what the designer or CAD tech or whoever is doing the design needs to do is measure basically the square foot area of each contour line. So your 381 line, your 382 line, your 383 line, so on and so forth. I'm going to input into here the numbers that are found from the example to make sure that it shows a relatively typical flood volume basin where as you increase in elevation, your capacity increases.
Hey, how's it going? That's for the data, or do you like call you to?
Okay, so once again, these numbers are just coming straight from example 4, and it's just to give a visual of what's going on here. Once you filled out these values, it auto creates this graph for you. So it goes ahead and tells you your storage above permanent pool, tells your elevation on the left of your basin, and then your storage in acre feet on your x-axis. They're also found here, cumulative volume above permanent pool. So we're going to use this later on because when we're designing a basin where we have like an orifice or an emergency spillway, we're going to want to try to locate those to be at certain flood volumes. So maybe it's the 25-year, the 50-year, or whatnot. And this is where I talked about way back in the beginning that we're going to come back to this graph in TR55 to find those volumes in those ratios. So it's going to go down to the drain rate. The CPV value was determined from runoff, and then the average release rate is a formula that takes the CPV value. And then now what it's looking for is for you to determine your outlet. This is like trial and error, similar to the infiltration basin. I think the idea is that you sit there and you come up with a design that fits your site. You know, you might think, okay, let me put my orifice, you know, halfway up the basin because there's a natural ditch nearby that I can connect it to, and the invert and you know, where it discharges just naturally works, and you may do this sort of stuff. And what this is going to do is it's going to help you determine your the area and the diameter, and then it also helps with determining if you need an emergency spillway, how big the emergency spillway needs to be. So the CPV storage elevation is determined from the acre feet of the required CPV here, so 0.35. So where you find that acre feet storage elevation is you go back to here and you find that cumulative volume and you figure out where's a good spot for that. I'm going to pause for a second because I know that was a little confusing. So what it's asking for you is to manually look at either your graph or your table and to try to determine about where the 0.35 acre feet storage is. So in this case, I'm going to just look at it graphically and say, or I changed my mind. I'm going to look at it. I'm going to look at it via the table, and I can see that it's somewhere between 383 and 384. So if I had to guess, it's around 383.5 or 383.4, and you can go ahead and just put that in there. And then this is where the designer is pretty much able to choose where to put the orifice. So since this thing goes up pretty tall, I'm just going to put 388, just about halfway up the way. And of course, okay, so it's not working because the CPV storage volume is below it. So for the sake of practice, we're going to go ahead and just say that this is at 390, that it's higher. Okay. And then discharge coefficient is typically 0.6. That's found throughout the CNMI, the Guam manual. And then what this is basically going to do for you is then it calculates your orifice diameter, both in feet and in inches, and then your required area. And it does that naturally, or it does that after you put in these three values. The 25-year release design is based off the orifice inlet elevation that you put in earlier, and then your 25-year storage elevation, which is, if we look at our 25-year, we have a runoff volume of 6.63. So probably around 389, 6.63, somewhere around here. Looking at like 389 point maybe 7. The weir coefficient from the example is 3.1. I have to, where that weir coefficient comes from again. I think it's based off the example of 4. It may be within. I wrote a mental note to make sure that what I'll likely do is just put a little note here that says where these come from to get the weir coefficient. And then this will, oh, also there's a computed total slot length. If you don't like the number it gives, which here is a negative number, say you've already designed this and you say you want your slot length to be 2, it'll do it naturally itself, and it'll tell you the computed max weir flow that it can handle, which is 13.74. If that's the max flow, let's say that our allowable in this case is right next to it, 13, right? That actually changes the value, it looks like. Okay. Yeah, so it changes the computed slot length now. So this is kind of useful. So let's say in your design, you've decided you want it to be 20, then we can change this to make sure that it equates to this, and that the cubic feet from the orifice and the max. This is basically saying that the max that the orifice can handle is 21, and that the max weir flow is 19. So this is basically saying, okay, if you did an allowable release rate of 20, you're good. You're under that max check orifice equation. Then this is once again just the same numbers as above. These are outlet barrel capacities. These are once again an optional choice that you can make, or if you have a barrel beyond this. For the sake of putting in, I'm just going to copy what example 4 does, which is a reinforced concrete pipe. It has a 42-inch. And then the estimated length was 70, and then the invert's at 380, and the outlet invert is 379. And then the barrels mannings, that's just based off the concrete. Coefficient discharge is 0.6, like it's been found in some, pretty much throughout the manual, is 0.6. And then the minor loss coefficient is also based off the type of material. And then what this does is it calculates all this to figure out your total discharge.
Like how much it would take a long time.
And then what it is basically going to tell you is what your emergency spillway, all this information is telling you what all your different flow rates are going to equate to and whatnot. And then you go here to your last piece, which is like the emergency spillway choice. If we did, say rectangular, we put it towards the top, of the spillway, and we say it's about 20. It'll have a max discharge of 188, which is well above what we saw earlier with all the different configurations, we have a total discharge of 3.32. So we're good. We're fine. Or sorry. We have an outlet barrel with 140 and whatnot, and then the 50-year discharge, which is right here, pre and post, is 26. That's the peak discharge at 50 years. So I think 20 feet, even 10 feet's more than enough. I think based off because of the fact that I chose so many of the configurations, both the barrel and the outlets and the orifices. I think it's pretty much saying you don't really need a weir. Now, if you didn't have any of that stuff, then your configuration of your emergency spillway would then increase. I will take a second because I'm sure there's plenty of questions, and that this is probably the most convoluted Excel sheet, and I think it's important to note that it's hard to work through this unless you're actually in the part of design where you're ready to start looking at this. So I'll pause there. Go ahead, Ken.
Yeah. Okay. Great. Yeah, I agree. This of all the options when we're on Guam, this is one that's kind of rarely used actually. But it's good that you're going through it, and I think there's a lot of hydraulic principles that are at play here to bring it all together. So it's really not that easy to go through without a good background of those principles. I just wanted to acknowledge though that this is, at least from the ones that I've done, we rarely use this approach. But I think it's a good tool, and I think it should be considered a little bit more. And the reason why I think we don't use it as much, particularly on outside the fence line, is discharging, having those orifices to discharge. A lot of times there's no infrastructure to discharge to, so it makes it kind of a challenge. And maybe if you know in your experience, can you speak a little bit to that? Maybe like if you have an area where your existing flow path goes, this probably could work okay. But if you're right next to your neighbor and you have a point discharge, sometimes it can raise a red flag. Can you speak a little bit to that? But I think this is very, very useful. We should be using it a lot more. It's just applying it out here, particularly when there's no, some areas where there's no mature system, it sometimes is challenging. Thank you.
I think that's a really great point. I think that goes to show like the geographic differences, right? Here in California, I find that it's a little bit easier to find those places to discharge into. I don't think we're as I guess valued on land. A lot of the area, especially working in the federal realm, a lot of times we're working near waterways already, just as the Army Corps does. And so I think that's a really good point. I think it's also important to note that you can kind of combine or couple these. So you can have a swell that leads into the basin if you have to put your basin farther away because of what you're saying. Like there's, whatnot. But I get what you're saying. I think that's a very good point. And I think that's the kind of the purpose of the Excel sheet, right? It's supposed to just be a capture everything sort of Excel sheet that could possibly be used. So then it gives designers the ability to have something that's been, I guess, outputted as a standard based off of the gears working behind the Excel sheet that are found in the Guam Manual and in TR55.
Yeah, no, this is good. I mean, and like you said, I think combining them is probably the way to look at it a lot of times. So thank you.
And Tyler, there's a question in the chat from Seth Colburn about, just the soils tab and how some of them have multiple hydrologic soil groups, and how can you tell which one to use? If you don't mind, I'm going to steal the screen just to answer that question. So if you're between, and specifically the question was on this one, the Tokchokina, which can be different, well, not in this area of interest that I've drawn, but in the spreadsheet, it could be either B or C. And if you're not sure, a safer bet is likely to pick the less permeable one, the higher letter C or D versus A or B. And that would be a safe bet. But if you really want to know, you could also go into the web soil survey, draw your area of interest, draw the area of interest where you're looking at, go to the soil data explorer, and through here, the soil properties, you could view the rating. And so even though it's showing here different, it would give you specifically what the group rating is for that area. But if that's getting to be too much, you could conservatively kind of probably pick the higher, less permeable one. And that's it. And I'll also put that, summarize that in the chat as a response.
That's super helpful. I think that tab's honestly probably better to use than the original one, which was the soil map, but instead the soil explorer that already just delineates it for you, kind of takes a step away where you don't have to use the soil tab on the Excel sheet. But either way gets you there at the end of the day, right? So thanks for that. All right. So yeah, as we keep going through like these tabs, they get a little bit funkier as you keep moving on, because now I'm trying to show values of a design that hasn't really been thought through, and this is where like going through example 4 is super helpful, because it basically creates the project for you to then walk through and see the values they use, where the values actually make sense, and it's not just me just randomly putting numbers in and then the system's getting mad at me, right? And so it's going to take time to get it right. I think there's going to be tweaking that's going to have to happen. I'm writing down notes as we go, so comments and questions are great. So I do extremely appreciate it. So moving on, we go on to swales, and then this is pretty self-explanatory. Before is the drainage area, and then this goes right into what we just talked about, where I said, you can couple your things. You can have a detention basin and a swale. You don't have to have just one or the other. This is asking right here, if you did use a detention pond, what was the classification? For this, I'm just going to act like we didn't do the detention pond, but if you did, you can select these, and it'll help affect the values down further. But anyways, I'm just going to leave it as is. And then the geological region we've talked about in the past, that's that figure. And then the water quality region, that's also from the same figure. And then the resource designation is based off those two values. One of the big things is finding the Q1 and the Q2, which is, thankfully it says right here, it's from the runoff volumes worksheet. So if we go to Q1 and Q2, runoff is right here. And then it's asking for Q1 and Q2. Let me make sure I'm in the right spot. Yeah. So it's just these two values, Q1 and Q2. Storm frequency year 1 and 2 right here. And then you would just use runoff 1.72 and 4.59. So I'm going to go ahead and put those numbers in, 1.72 and 4.59. And then, yeah, this was we did this back in the beginning. These are pre-populated based off your curve numbers and whatnot. Okay. And then I already filled out these numbers. These are not, definites like you have to do. These are recommendations based off the Guam manual. This is from figure 3.13, and it goes through the recommendations. There is a max depth requirement for swales of 18 inches. and that's where the 0.75 comes from. But the majority, because it's based off the average height of the maximum, yeah, it's based off that information. So these don't have to stay, but they're I left them as is because they're all the recommended design configurations for a swell. And then what that does is gives you the required dry swell size area. And then what we put here is our available length. So I'm just going to put in numbers once again, and then I'm going to say that we're well above our area. So I'm going to say we're at 400, and then I'm going to say we end up at 390. And then the Manning's value is based off the soil type or the type of how you what your swell is. So if we do grass Bermuda 0.4, that's what I'm going to base it off of.
Well, you can do, you do this at a location.
Since usually grassy swells are pretty typical, pretty standard. Okay. And then the last thing, or the next thing it's going to do is it's going to check to make sure that the available slope that you determined is good. The typical best practice is 1 to 4%. This calculated it to be 2, so we're good to go. The volume top width and bottom width are calculated here. And one of the things that the Excel sheet or the sheet does is it captures to see based off the configurations that you gave if you have a big enough bottom width of 2 feet, which is the minimum, and it goes ahead and highlights it red if you didn't, and then it will basically just say, okay, I'm going to go with the 2, which is what it's doing right here. So it says, you know, if the bottom width is less than 2, then it's just going to use 2. So it's kind of nice. This swale sheet kind of is helpful because you just kind of put in the numbers, and it does a lot of things that it auto populates itself. Interesting thing is if your slope is greater than 2, then it puts in check dams automatically for you, and it tells you how often and how many would be required. So for the sake of this, let's say that it's too big. Okay, so let's say that our available slope is 3.3 due to site conditions, right? Now it's going to say, yes, check dams are absolutely required because your slope is not greater than 2. It tells you how often automatically, and it tells you how many. So this is kind of nice because it kind of does the thinking for you. Just super helpful. And so once again, see, I changed it back to 2, and it says, no, they're not required. So now what it's going to do is check erosion and whatnot. And so you just go ahead and click this macro. And here we go. It actually worked. And then it will give you your required depth. It'll determine what you absolutely need your required depth to be. It'll make sure that your velocity is less than 5 feet per second. And then lastly, it needs to make sure that the 2-year storm has proper conveyance. It'll calculate it. And it says, there you go, 0.3. So your required depth, if you were doing a swell, would be based off these, and then it calculates the required depths, freeboard, all that good jazz, and you get a total depth of 1.3. So much different than the detention basin. It's much easier. It's not as many, complex, principles going on. Is it's a V ditch, right? Or I guess a trapezoidal ditch. And so it kind of just calculates these numbers for you. And so you would end up with a filter bed depth of 2.5. You'd have a length of 500 and then a bottom depth of 1.3. So you could average it out to 1.5 if you had to, right? And that's swells. So I guess in my opinion, I think they're a little bit more straightforward than the rest of the choices so far. I'll pause there before we move on to bioretention. Okay.
Yeah, let's just get some feedback too from the group. How's everyone tracking all of this? You guys still there? You see this tool being pretty useful so far? And we got a couple thumbs up. That's good. Good to hear. Right. All right, Tyler. Back to you.
All right. So bioretention is going to look pretty similar to the swell section. I think it's also important. Let me just quickly, I want to show, because when I was first doing this development, I thought bioretention was a little sort of foreign to me. And so I thought it'd help real quick just to show the Guam manual that's showing bioretention and whatnot. And it's kind of like, I don't know if Guam does as much of this bioretention design work as I've seen in California, but once I saw this picture, it really helped like click for me. I've seen a lot more of this practice happening in my town here in Sacramento, where instead of just having a gutter near the walkways, they put a little sort of riparian wetland area to allow for, I guess, natural filtration. So I don't know, has people seen this sort of practice done in Guam, or is this sort of a foreign thing? I guess I'm just asking the group as a general if people have seen this before. Go ahead, Ken.
Yeah, I've actually never really done this particular one. We've kind of done a little bit of a modification on the swale side, where we do kind of a wet swale, but I've never really done it where it's intentionally bioretention. No, I see the
Okay.
concept, but I still kind of struggle with it. But
Okay.
I've done something a little bit for the, again, similar concept, but for a wet swale. But really, I was really just trying to do a dry swale. Was really what I was trying to
Gotcha.
do. So I agree, at least for me. I'm sure others might have. I think I have seen it. There are some parking lots that I think there's some designs where they've taken a stab at this and used it pretty well. But I haven't.
No, that's super helpful. I think I just quickly did a Google search, and I'll show you what it. I think this picture I just found does a really good job at what this looks like if in like actual real world applications. So this is basically a good idea. Oh, sorry, it's super blurry, but it's becoming more common in California at least, and maybe who knows, maybe it starts to become more common in Guam. But it's basically your gutter off your street goes into this. It's kind of like a miniature infiltration basin in a way. It comes into this area, and then there's drainage underneath all of this that allows for the water to continue. So I thought this was helpful to like show because I wasn't sure if this is a very geographic niche or whatnot. But hey, who knows? Maybe this will become more now that you guys have seen what sort of how it looks. And like I said, if you just look up bioretention, like sidewalk gutter, they're becoming more and more commonplace in California. And it's just like I said, it's just a natural way to help filter out, runoff from the city. So hopefully that was
Thanks.
a little helpful. Oh, go ahead.
And Tyler, there's a question on how would the calcs differ if there were any bends? Was that Seth? Was that question on swales or bioretention? Swales. Oh, sorry, that was for the swales.
Yeah. I think you don't. I don't think the bends whatnot.
Yeah,
From what I've seen,
think
they
it would
don't
make that much of a
affect it.
difference.
I could see where Seth is going with that, and I think where you capture that is your length, right? So if you instead of just doing a straight shot from 400 to 390 over 500 feet, if all of a sudden, just because, let's say this depth isn't practical, right? If you were to make it sinusoidal, that's technically you're increasing your available length, right? Like instead of this being at 500 feet, now all of a sudden it's at 750 because you're measuring the length of the alignment. You're not necessarily measuring the from 400 to 390 on the contour. So now all of a sudden I've just increased it to 750, and that just brought down my depth to 0.7. So that it may work out to where, for whatever reason, you do want to have more length, and that's how you capture it is via the available length here. Really all. All right, bioretention. So this, from what I understood, is maybe more of a niche thing, and I did notice that there wasn't much of it shown in the examples as well. So this is starting to make a little bit more sense why it wasn't shown. But if we just went ahead and did it anyways. So once again, these are those numbers that we talked about that are kind of just standard practice, 1.7, 4.6. So it follows sort of the same mantras as well. And then the last thing you have to put in for this sort of stuff is time of concentration. It gives you the time of concentration that you calculated way back here of the post development, 0.23. It puts it off to the side for you, and you can just go ahead and say, okay, I'm gonna go with that one. And then it gives you your required filter area, volume, all that good stuff, peak volume, abstraction ratio. So it's a little underdeveloped, but it does give you some valuable. I think the biggest one being the required filter area. I think it's probably one of the biggest values for this section. And then lastly is sand filter. Once again, I will show, I think sand filter and bioretention are pretty close to the same, but here's a figure from the Guam manual. Once again, figure 3.1 that shows that this design configuration, to kind of give an idea of what the sand filter is doing. So it's really similar, in my opinion, to the bioretention, but it's trying to get that filtration via sand instead of maybe vegetation and whatnot. And that's why you have this really large piece of the cross section that's just clean washed concrete sand. And then some sort of perforated underside drain. And then once again, this is very, it starts off very similar once again to the other two where you have your 1.7 and 4.6, your two values. And then this is where I'm going to admit my shortcomings. I haven't done a sand filter design, and so these sort of numbers here are little outside of my expertise, and so it's kind of hard for me to know these values. But I'm assuming, long story short, you fill these values out, and then it's going to give you your average depth that it assumes your sand filter to be at, and then you can determine what sort of additional features you have via these different tabs. So there's a flow diversion structure. If you have a filtration bed chamber, if you have a sediment bed chamber, and then at the very end here, it's going to do a volume check to make sure that your chamber height is greater than your available head. And so it's just a check at the very end. I don't know if, I'm wondering if this has the same story as before, where it's kind of like, it's here, in case that this niche is used, but I don't know how much. I could see it being more utilized than the bioretention option. Once again, I'm not sure what the general design kind of community of practice utilizes. It sounds like a lot of infiltration basins. That's about it. The Santa Barbara Urban Hydrograph. I don't know, Jessica, I don't know if this is a legacy thing. I'm unaware of what this is utilized for. I couldn't find in any of the examples utilizing this hydrograph.
Let me check
Okay.
if it was in a TR 55 reference.
Okay. So maybe it's a different way to figure out runoff values using a different methodology. And all the examples I saw, I didn't see this tab being utilized. So I've kind of kept it there, but wasn't sure if it's a legacy sort of rendition or whatnot. That is how to use the Excel sheet. It's a lot. I understand that. And it's going to be one of those things where I think you have to use all the tools available to yourself and slowly but surely like try to utilize it. So like I said before, you have your Excel sheet that was provided that's completely blank. You have Guam example part 4 or Guam example 4 part A, which comes straight out of the Guam manual that actually has these numbers and values put in, and they work correctly. They don't give you negatives and the macros aren't jacked up like I showed earlier. And with this came a Word document. And this is a huge helpful use. Like this is pretty much how I taught myself how to use this Excel sheet. It's 55 pages long. It's super long. But what it does is it goes through the example you're doing. It shows your dry swells. It shows your catchments, all that whatnot, tells you your values. And then it actually goes way more in depth than what I provided. So it'll go through and actually explain to you why some of the yellow features that are calculated, how they're calculated, why they're calculated the way they are. So this is something that you use to, say you're doing your design, you look back and you're like, I'm not really sure, Tyler kind of glossed over this section. You can come through here and read more about it. So this is kind of like a really good instruction manual when you want to go really in depth. And then, like I said, I'd use the PowerPoint as your first start, and then the Word doc is like the next place. And then if you still are not sure, I think the Guam manual is like the next, the last final check of sanity to use. And I think I've gone through most. It is 5:10 over here, and I am getting foggy. So if I'm missing things and people are confused, please, this is the time to speak up.
Yeah, Tyler, thank you so much. This has been really great. I think it shows a lot of potential, how to get ourselves streamlined out here, using an effective tool that, basically can be used by designers and, verified with our regulatory permit divisions at the Gov Guam. So I know there's been a lot of information to absorb, but yes, let's open this up for some good questions and comments. Things maybe you think we should look at, ways to possibly improve it. The floor is yours, guys. Let's take this opportunity.
Yeah, and just to answer the Santa Barbara Urban Hydrograph, that's just a simpler way to generate a hydrograph, a flow hydrograph over time, if you needed to make one. And it's simple enough that it can be in this spreadsheet.
Thanks, Jessica.
Yeah. Ken,
Ken, you got a comment?
Oh, yeah. Thanks again. I'm trying not to be too talkative. Thank you. This is really good stuff. I did my own attempt at trying to do this. I think I've had my template, but yours is a lot more cleaner and user friendly. So this is great. A couple of questions was I think you acknowledged it. The infiltration rate is a pretty important factor, and I saw the tables that were provided. It's just through experience, those infiltration rates are really dicey, and a lot of times, we try our best to rely on what we get in the field, but the numbers that are there, I'm not sure how, if Guam EPA or DPW would, how they would take to using those numbers, maybe in the absence as a planning level that could be done. But I just a caution on those numbers. But yeah. So anyway, no, the other question I has, and I might have missed it. This analysis doesn't really, the flow rate, Q CFS doesn't really come into play so much in a lot of this analysis. But did I miss it? The spreadsheet, did you guys build in a macro that calculates Q using either TR55 or maybe the rationale method? Was that like already built into the template or the spreadsheet that was sent out? Or was it was not, it's not a factor that's not really applicable directly here. You follow my question?
Yeah, I think
oh, go ahead, Jessica.
I think it's on this TR55 tab, row 25.
Okay, so you built that TR55 modeling is built into that tab. I guess that's where all those rows were at. But so can you zoom? Is that CFS that I'm looking at? I can't see it too well.
Hang on, sorry, I was on the wrong screen again. Okay.
Yeah,
Okay, great.
it is in CFS, and then it's for the different frequency events, pre and post development.
It's good stuff. Okay, great. Thank you.
Yeah, sorry, Ken, on that. I think my discipline kind of showed itself here because I'm not H&H by practice. I'm more on the design side, so usually I get the numbers from them and they tell me what my basin's supposed to look like. So I probably brushed over something that was probably really important.
Sorry. The reason I asked was in my template, I couldn't build it into my spreadsheet. I'd have to tell my designers to run TR55 separately or use the rationale method, and it was just an extra step to go to another model. But having it all built into the spreadsheet is really useful. So that was good. Thank you.
Good stuff. Steven, I see your hand up.
Hello. Hi, I just want to say great job on the presentation. One thing that I may suggest is if Guam EPA could probably review this or make note of which items they usually provide comments and feedback to applicants on what they're going to put a permit application on hold for a trend of they notice maybe people aren't following certain requirements of the stormwater manual, and then how that we have notes on the side check that this is greater than this or this is less than that. Maybe it could be in this spreadsheet on recheck this value to make sure it complies with the stormwater manual, if that makes sense. Just because the intent is to make sure all of the applicants for permits are following the stormwater manual. So if GEPA knows that people usually aren't complying with a certain, maybe the water quality volume or certain requirements, that it could be flagged to contractors when they use this Excel spreadsheet.
Yeah, that's a great point, Stephen. I already wrote it down. Yeah.
And then one other comment I could suggest is these are the 4 main calculations, and then one other calculation that Guam EPA requires is for temporary storage. So it's a pretty straightforward calculation, but maybe if there's a summary page on the requirement of based on your project size and how much temporary storage you need, if that could be one of the printouts also.
That's another good idea. Do we have anyone from Guam EPA and DPW on? Actually, I'd like to hear from them. You know, we have some good suggestions here from Stephen and
Yes, we noted that. Thank you so much for those comments.
okay. Marikar, just to you know, not to put you guys on the spot, but how do you guys feel about the tool the second time around? Do you feel like you could get some potential use out of it and, you know, possibly improve the process?
I think so because, you know, from this time that, you know, we're really short of resources, I think this one will be helpful to us to make our review a little bit faster. Thank you so much.
Hey, Matt.
So I do want to comment that, you know, Guam EPA with Brian Bearden before his departure, like, you know, was heavily involved in the, you know, the final product, I guess, especially with the Guam update for the manual. So, you know, this is something that was previously vetted.
Yeah, and this actually, you know, just to give some background on this as well, everyone, this was actually the Guam has set up a group called the Guam Silver Jackets. It's a collaboration between the federal and local agencies, kind of like a meeting group where we can address different situations out here in our community that maybe we need ways to improve upon or you know, address some concerns off of it. And so this collaboration meets, you know, supposed to be like once a month, but maybe once every 2 months and so forth. And it's really just, you know, catching up on what different agencies are doing and different challenges that we are facing. And this is one of those outcomes that came from it. I think Brian Bearden, when he was at Guam EPA, this was one of his main things, you know, trying to get everyone on board, using the same numbers, using the same ways to calculate it, and making that review easier. So it's a pretty good couple first steps for improving some way our systems working here. Anyone else some feedback? I believe the idea for us was eventually getting this possibly into like the Guam Contractors Association to do maybe some, you know, yearly training or update or get people familiarized of how the tool works, and keeping everyone, you know, on track as we try to get it more implemented on a regular basis. Feel free to talk. It's to get some, you know, discussion off of this. So I see Nadia, you have your hand up.
Yeah, so Guam Contractors Association is really interested in working with Guam EPA and you know, other stakeholders to kind of develop a program so that we can get all the contractors on board with improving the quality of submittals that go to Guam EPA, and then in turn improving the review period. So yeah, that's something GCA is already working on.
That's good. And you see this tool being helpful for you guys?
Yeah, very helpful. I think this training was great, and we got to do more things like this.
Thank you, Nadia. Anyone else? Some feedback? Some concerns?
Hey, Mike, this is Ken again.
Hey, Ken.
I don't know. I think I raised my hand too many times. The button's not working anymore.
No, you're good. You're good. Keep providing us some feedback.
I don't know if anyone's. There's also, I think the Guam Contractors Association is also is key. There's I'm sure you've reached over to Sammy. There's also the what's that called? The Guam Society of Professional Engineers. kind of an abridged version of this at their monthly luncheons would be a good tool, or sharing it with their group. If you need a point of contact, Mike, you can reach out to me. I can do that if they're not already on this email or this list, this group here. But so the one comment I have, it was acknowledged at the beginning, and I know it's created a little bit of confusion. Is the transportation group uses a different manual? It's kind of an old school. It's kind of a mixture, I think, of the newer stuff and the older stuff, and they've meshed it all together. I think it's best if we had one common tool like this tool here. Is there any update on that? Does anyone on this call able to update? Are we still like kind of in that scenario where we got to use two different kind of approaches?
Yeah, this is Matt Santos. That's by executive order, and if we were to, or somebody else talking. Hello? Okay. So, assuming that we kind of fulfill all the things we kind of set out to do on our MS4, we'd probably have to update it as well, especially for, major roadways that have stormwater systems. But yeah, currently, unless we amend the executive order or come up with some new guidance or adopt this one, it's going to remain the same, at least until those updates are made.
Understood. Yeah, I know that's a challenge. And so if you brought MS4, because the transportation manual is largely around roads and stuff. That MS4 is a lot of the culverts and discharges. That really, it's not really just roads. It's larger stormwater systems. So I think using the TR55 method is. So anyway, I think that's good. I think we've got a lot of good information. So keep moving forward.
I think that's a good idea, just to incorporate two manual in one.
Yeah. I know I was kind of involved back in those discussions. One of the challenges, and it was brought up right at the beginning of this presentation, is the smaller design storms, kind of 1, 2, 5, 10 are probably okay. But once you get to the 25, or if you have to go larger, like 50, that two-tiered looking at it really has an impact. And I think it's been EPA's position to use the CNMI Guam manual. They're that one. But if you use the NOAA data or any other data, it doesn't really look at it that way, like the late Dr. Lander did. So a lot of times engineers, you can see the difference right there. Is the 25 and 50-year storms. It's there's a big difference there. And I know EPA's position is to use the Lander report, but sometimes we then we're kind of in a position where we're trying to we got to get clever and kind of hokey ways of looking at the numbers. I think more discussion around that would be really useful in our kind of as a whole. And I think that was the driver for some of the engineers to push for that transportation manual to follow sort of the older numbers. But yeah, that 20 and 27 number for the 25 and 50-year storm those are big, and sometimes they prove very challenging to meet. Most of the time, they prove very challenging to meet. So I think a little more discussion on that is definitely needed. I think we're not gonna answer it on this, but that's for that silver group, that silver jacket group. That's a really good talking point to see what's the right, where do you land on that, and what systems should be looking at that, and maybe what systems can go to the other Atlas 14 approach. In my opinion, I think it's maybe a combination of both, depending on the risk and likelihood of impact for your system.
Yeah, and I agree. There's a lot riding on this one technical report that, it's at the end of the day, it's just one report that is saying to use these different numbers. But all of the science, in some of our other studies, we've done our own kind of site-specific analysis, and they do lean more towards the Lander numbers being more accurate than the NOAA Atlas numbers. But it is quite a significant jump for these larger events. You can imagine the 100-year and 500 years quite large. So I think there's some type of analysis that still also needs to be done to just kind of strengthen this theory a little bit more.
You know what I've seen there, and I'm sorry if I missed it. There's another report done by I think it was NOAA, where it's not this is like a 24-hour period, but if you look at the intensities of our storms, we have really high intensities. I mean, it's and that high intensity is one of the reasons you see a lot of things flood out real quick, but then it kind of goes away almost as fast as it came. But it's I always thought that was an interesting thing to look at because it forces us to kind of upsize our culverts and stuff. But as far as the storage goes, you know, maybe we don't need as much storage, but we do need the ability to move that water through our catch basins and stuff. I always kind of look at it. I always thought that was interesting. This our intensity of our storms are, which is picked up in this the lander analysis. But I don't know, just 20 and 27 inches of rainfall is big. But we do see it. I agree. We have seen it. I think Ting Ting and recent storms have proven Lander to be right. So I'm not going to argue that.
That's a really good point you bring up, though. That one is very interesting too. What you're talking about, like the intensity that we receive in a very short amount of time, and that does dissipate, right? You know, probably as fast as it came down. But yeah, that is an interesting point to look at. See how we can I don't know, find them a happy medium on that for our design standards.
Yeah. And again, it's probably go ahead.
I was just going to say, I'm wondering if it's something as simple as like, you know, we saw in the infiltration basin tab, there was a analysis question you had to answer about like basically risk. It almost sounds like that, you know, my Army Corps brain's going off right now. And there's a lot of things we do where there's multiple iterative processes of what's the risk of this structure failing. And based off that answer, the requirements are vastly different. And it sounds like that's what I'm hearing, is that there needs to be some sort of requirement set forth in terms of risk of failure to determine which one to use, if that makes sense.
Yeah, that could be an interesting way to look at it, because your larger stormwater systems, you know, like in culverts and things where there's high development, you know, the higher risk, you know, you certainly want to make sure you're protecting there. But when you got sort of low impact, sort of smaller commercial locations that are having to do larger catchment basins and you know, stormwater storage basins, maybe the risk is lower. Maybe we can kind of shift over to a lower risk approach. But yeah, again, more discussion on that's needed. I'm glad you guys are, you know, we're having this discussion, because that would be really cool to guide it. And it's what I do think. I wasn't there, but I do think it's one of the reasons the transportation group, back when they did their own manual, that was one of the drivers. I would have to think, because if you look at their manual, they don't really pull those numbers up and use those higher numbers. So oddly enough, though, they have the bigger risk. But yeah.
Yeah, good stuff there. Thanks, Stan. That's good discussion going on. I appreciate that. We did have something in the chat here. Captain DeGrange, hopefully I'm saying that correctly. Any thoughts to share with the UOG's engineering school? Most definitely. We're trying to get this streamlined out there. Trying to find the best venues in which to alert people to, you know, this possibility of this tool that's out there. That we're all able to get our calculations, you know, verified and you know, more direct. So definitely, yeah, we would look into that engineering school. And Ken, going back to your idea of, you know, possibly introducing this out at the SAMI meetings or at the Guam Society of Professional Engineers. Definitely
right.
Looking at that as well. That as great ideas off of there. Anyone else? Nice. Okay, well, we are at 10:30. I don't want to hold anyone back if you don't feel we need to stay back anymore. I know this was kind of brief. What's our departing thoughts here, Jessica and Tyler? I'm thinking it'd be we would be very interested to see you guys use the tool, play around with it, find the areas that you know, especially the sheets that you would more frequently use, and see how that works out for you, and give us some feedback. We're looking to get this more updated, streamlined, and accurate as best as possible. And this goes for both our review agencies and for our designers. Play around with it, see what ways we can actually improve upon it, and we would love to take that in and just possibly host another one of these with those updates that you guys can provide. Good stuff in the chat here. Again, providing it to Weary and some other folks. Thank you for all that. Jessica, Tyler, any departing words?
Oh, nothing from me. Thank you for your time.
Yeah, I'm good as well. Thank you guys for attending. This was a awesome turnout.
Hats off again to Tyler. I mean, this was a big tool when it was first initially designed. There was a big group that was, took part in that. And we had Tyler jump in late on it to try and go through it and really figure it out. Because even at first we were having a little, we lost some of those guys who did the design of it and trying to figure out how it all works. So hats off to him. He did a really good job. You're now our tool master here, Tyler. We're gonna have to always go back to you for this, but hopefully the knowledge is getting passed out to everyone else, and we can, like I said, we can provide this locally, in person, possibly, to something that maybe like the Guam Contractors Association or whatnot. We can get additional training on it. Matt, anything from you? Departing words before we end this?
No, just thanks for everybody for participating. And I'll just wait for the video file so we could upload it to our website with the rest of the materials.
All right. All right. Thank you, everyone. Really appreciate your time.
Thank you.
Thank you.
Bye now.
Thank you.
Thank you.
Thank you.